So hello and welcome everyone. I am Jay Dalsaniya and in this video we are going to study the question merge two sorted linked lists in reverse order. So this question is very simple and easy to understand. So without any delay, let's start and understand what the question is trying to say. So before starting the video, I would like to give you a target of 50 likes in this video. So let's hit the target of 50 likes in this video and do comment down what was your solution for this question. So let's start. So in this question, you will be given two linked lists of size n and m, and they are sorted in non-decreasing order. Okay, so basically the task is to merge them in such a way that the resulting list is in non-increasing order. Basically, it should be in decreasing order. So basically, two linked lists will be given to you, and both the linked lists will be arranged in increasing order individually. And now after merging them, the resultant linked list should be in decreasing order. So that is what the question is trying to say. So now let's try to understand with the help of the example given over here. So in this example, you can observe n is equal to 2 and m is equal to 2, both the list of size 2. So now let's say if I merge this linked list, so the linked list will look something like this. But this ordering is in increasing order. But they want what? They want the linked list to be in decreasing order. So they want the merging in this manner. So the output for this test case comes out to be 4, 3, 2 and 1. Right? So similarly for the example number 2, where n is equal to 4 and m is equal to 3, this linked list contains 5, 10, 15, 40 and this linked list contains 2, 3 and 20. So now what I will be doing, I will be taking the last element. So let's say 40 and then I will be taking 20 and 15, which is greater 20, and now I will be taking 3 and 15. So I will be taking 15 into consideration. So now 3 and 10, I can see 10. So now 3 and 5, so I will be taking 5. And now this linked list has been exhausted. So now this 3 and 2 will be attached over here. Right? So this is the entire linked list, and now the output of this test case comes out to be 40, 20, 15, 10, 5, 3 and 2. Right? So this is what the question is trying to say. I hope you understood what the problem statement is. So now let's try to focus on how to solve this question. So in this question, various implementations are used, that is merging two linked list and how to reverse a linked list. So let's try to discuss the approach. What can be the approach for this one? So I will take the input number 2 and I will be working on this input and I will be explaining you what the solution is. So now over here, what is the issue? The issue is that the linked list given to you are already in increasing order, and what the question is trying to say, the question is trying to say that they want the output linked list to be in reverse order, basically in decreasing order after merging them. So now if you are wondering that, let's say if you will merge both this linked list in increasing order and then reverse that linked list, then you are totally okay with that. You can apply that approach as well. But now over here, what I'll be doing, first of all, I will be reversing both the linked list. So I'll be applying the reversal algorithm, a basic reversal that can be done in order of n time complexity, right? So if I reverse both this linked list, so I'll be getting 40, 15, 10 and 5. Similarly, L2 will also be reversed, that would be 20, 3 and 2. So now this both the linked list are available in what? They are available in decreasing order. So now if I apply the merging of both the linked list, then it can be easily merged down to a single linked list that will be in decreasing order. So now how this merge process will take place? So let's try to understand how the merge process will take place. So now for merging, what I'll be doing, I'll be taking one dummy node, and the dummy node will be nothing but it will be -1, and there will be one pointer that will be saying current node, which it will be pointing to the last node of this dummy linked list. And along with this, I'll be having two different pointers, that is T1 and T2. So T1 will be pointing to the head of this reversed linked list and T2 will also be pointing to the head of this reversed linked list. Now which is greater between T1 and T2? I can see 40. So I'll take the node 40 and I'll attach it over here, and your current pointer will move forward, right? And what I'll be doing, I'll be detaching the next of current. So I'll be making the next of current null over here. So if as soon as I make the next of current null, this linked list will be not the part, this node is not going to be the part of this linked list. And before detaching, what I'll be doing, I'll be making sure that T1 has been proceeded further to the next node. Now again doing the same process, I'll be comparing the value of the T1 and T2, which one is greater one. I can see T2 is greater. So next of current will be pointing to this node T2. So basically over here you can visualize 20 will be present and current will move forward, and the next of current will be made null. But before making the next of current null, this T2 will proceed further over here, and now you can make the next of current null. So basically this node will not be the part of the linked list. Now T1 and T2, which one is greater one? I can see 15 is greater, so I attach the node over here and move the current pointer forward. So after moving the current pointer forward, make sure to move the T1 forward, and now what you can do, you can make the next of current as null. See, the next of current needs to be made null each and every time. If you don't do so, then there will be cycles possible in the linked list after merging, and that might create an issue. So now again the same thing, T1 and T2, which one is greater one? I can see T1 is greater, so I'll be appending over here, and current will move forward and T1 will also move forward. And now what I'll be doing, I'll be making the next of current as null, right? So now again following the same process, T1 and T2, which one is greater one? I can see T1 is greater one, so I'll be attaching 5 over here, move the pointer current forward, and the next of this T1 is already null. So if you move T1 ahead, you will be traversing the entire linked list and you will be encountering null. So your T1 becomes null. So that means list 1 has been completely traversed and now only list 2 is remaining. So if in such scenario, if T1 is becoming null and T2 is not becoming null, or vice versa, you can simply make the next of current point to either T1 or T2, whichever is not null. So I'll be making this next of current point to T2. So basically it will be pointing to 3 and then node number 2, right? So this is the entire reversal process, and in this manner you can merge two linked list, and basically the output linked list is going to be in the reverse order. So where is your answer linked list? So basically the next of node, the next of this dummy node is going to be your answer linked list. So you can just return the head of the node after the dummy node, and that is going to be the answer or the output linked list. So this is how you will be merging two sorted linked list, and in the reverse order they will be looking something like this. I hope you understood the entire process, and now what I'll be doing, I'll be showing you the algorithm for the same so that you can get a clear understanding of it. So I'll be writing down the steps of the algorithm. So if you are using any different language, then it will be helpful to you in order to write down the code. So let's understand the algorithm. So the algorithm is pretty simple. So first of all, what I'll be doing, I'll be reversing both the nodes. So I'll be needing head 1 is nothing but the reversal of the current node, basically the current linked list, and head 2 is nothing but I'll be reversing that as well, head 2. Okay, so both the linked lists have been reversed. So now what is the next step? So the next step is to take the temporary nodes. So let's say T1 is currently pointing to head node, and T2 will be pointing to what? It will be pointing to head 2. And now what else I need? I need the dummy node in order to store the answer, right? So let's say I have a dummy node, and dummy node will be containing -1. Okay, so basically it is a node. It is nothing else but it is a node, and I need the last node of this dummy linked list. So for that I'll be using one variable, that is current, and it will be pointing to the last node of this dummy linked list. So that will be currently pointing to dummy node, that is the head of the dummy linked list. So this many variables are required. So now the third step. So this third step is the merging process. So basically what I'll be doing, I will keep on merging while the node T1 is not equal to null and the node T2 is also not equal to null. Both of them should not be equal to null because I need the comparison between T1 and T2, right? So now I'll compare the values of T1 and T2. So I'll be checking if T1 dot data, if T1 is greater than T2, so I will append the node pointed by T1 at the end of this current node, basically the end of the dummy linked list. So what I will be doing, current dot next, basically the next of current will be pointed to whom? It will be pointing to T1. Now what I will be doing, I will be moving the T1 node forward, that is T1 is equal to T1 dot next, After moving the T1 node forward, what I'll be doing, I'll be detaching the entire node from the linked list. So basically I'll be making the next of current. Before making the next of current, I'll be moving the current node forward. Current is equal to current.next, and over here current.next, after this I will be detaching the node from the list number 1 is equal to null. Okay, so this is if T1 is greater than T2, then this is what I'll be doing. Else if T2 is greater than T1 or both of them are equal, then what I'll be doing, I will be making current.next point to whom? It will be pointing to the node number T2, and the T2 will move forward, that is T2 is equal to T2.next, and then current is equal to current.next, and the next of current will be null now. Current.next is equivalent to null. So this is the entire merging process, and after the end of this merge process, it is possible that the list number 1 is completely exhausted, but list 2 has few nodes remaining, right, and it will be pointed by T2. So what I'll be doing, I'll be checking if the T1 is not equal to null. If T1 is not equal to null, that means list 1 still has some nodes inside it, right? So I'll be making the next of current.next point to whom? It will be pointing to T1. Similarly, if T2 is not equal to null, I'll do the same thing. Current.next is equivalent to T2. So you might be wondering, what if both these conditions are valid at the same time, then it will create an issue. But this will be not possible, because you will exit the for loop if and only if your T1 is negative, basically if your T1 becomes null or if your T2 becomes null. Okay, then and only then this for loop, basically the loop will exit. So both this condition will not be true at the same time. It is not at all possible. And now at the end, the sixth step is to return the answer. So where is your answer? This was your dummy node, right? And over here, this were the answer nodes, right? So basically the next of dummy node is going to be your new head node. So you'll be simply returning next of the dummy node. Dummy node dot next. You can simply return the next of the dummy node, right? So this is the entire solution, entire algorithm, and this algorithm can be taken as a reference when you write down your code, right? So what will be the time complexity of this approach? Let's analyze the time complexity. So over here you can observe this is going to take order of n time m, right? Basically we are just reversing two linked list, and this is going to take order of, let's say, n or m, whichever is maximum, and whichever is minimum, that many times this for loop will run. Minimum of n comma m, right? And this is going to be constant order of 1 operation. This is also going to be order of 1. Okay, so the overall time complexity of this approach comes out to be order of n plus m, right? And I'm just considering this reversal process, and the merging process is going to be minimum of n and m, so I'm not adding it over here. So the overall time complexity comes out to be order of n and m, and the space complexity will be constant in this scenario because we are not using any extra space. The merging process has been done on the initially input node itself. Whichever nodes were given, I have used the same nodes in order to get the answer. So now let's deep dive into the coding implementation part, and let's get this solution done. So over here I have implemented the entire algorithm in Java, but the same can be implemented in other languages. Just take the reference of the algorithm which I already showed you, right? So now this is the process. So first of all, node 1 and node 2 are the head node of both the linked list, respectively node 1 and node 2. So I'll be reversing both the nodes, node 1 and node 2, and then I have created a dummy node with the value -1, and this current node will be pointing to the last node of the dummy linked list. Now two temporary nodes are required, temp1 and temp2. Both of them are initially pointing to the head node of the linked list 1 and linked list 2. Now this iteration will start. So while temp1 is not equal to null and temp2 is not equal to null, this loop will keep on running, right? So if temp1 is greater than temp2, what I have done, I have attached the node temp1 to the next of current, and I have moved the temp1 forward, and I have moved the current pointer forward. And at the end, I simply need to detach the node which I have attached to the dummy linked list, right? So I have made the next of current as null. Similarly, the same thing will be done with the temp2 if temp2 is greater than temp1. And now after the iteration over the entire linked list, temp1 or temp2, any of them can be null. So if temp1 is not equal to null, then what I'll be doing, I'll be making the next of current as temp, and if temp2 is not equal to null, I'll make the next of current as temp2. And at the end, where is your answer? The next of the dummy node is the head node of your output linked list. So you can simply return the head of the dummy node, basically the next of the dummy node, right? So now let's try to submit this solution and let's see the acceptance. And we can see that the problem has been successfully submitted. So that was it for in this video. I hope you really enjoyed this video, and if you really enjoyed this video, do hit the like button and share down your approach in the comment section below. And so that was it for in this video. Thank you for watching. I will be seeing you in the next video. Thank you.